Ever wondered about the nature of information, if it is physical or non-physical? This question has sparked debates among scientists and philosophers alike. At the heart of this discussion was the late Rolf Landauer, a physicist who boldly proclaimed that information is inevitably inscribed in a physical medium and that it is not an abstract entity. Landauer's assertion may seem reasonable at first glance. After all, when we think of information, we often picture physical forms like books, computers, or DNA strands. But is that all there is to it? Can the essence of information be reduced solely to its physical medium? Enter Roger Penrose, a renowned mathematical physicist. He presented a counter-argument, contending that information has an existence independent of its physical manifestation. This argument is not merely a philosophical musing, but a perspective that finds grounding in the world of quantum physics. Penrose's viewpoint was dismissed by Landauer as a quaint notion. However, it paints a picture of a universe where information isn't confined to physical entities but exists independently of its physical representation as a fundamental aspect of reality itself. This idea may seem abstract and intangible, but it has profound implications for our understanding of the universe. These contrasting views present us with a fascinating paradox. On one hand, we have Landauer's materialistic perspective that firmly anchors information in the physical world. On the other, we have Penrose's perspective that liberates information from the constraints of physicality. This debate leads us to question, what truly is the nature of information? Is it bound by physicality as Landauer suggests? Or does it transcend material constraints as Penrose argues? The answers to these questions have far-reaching implications, not just for our understanding of information, but for our comprehension of reality itself. Could information truly exist separate from its physical manifestation? Let's delve deeper. Quantum teleportation has shown some intriguing evidence contradicting Landauer's claim. Let's take a moment to dive into the mystifying world of quantum physics, where teleportation is not just a sci-fi trope, but a reality. Quantum teleportation, in essence, is the process of transferring quantum information from one location to another without the information traveling through a physical medium. This is achieved through a phenomenon known as quantum entanglement, where two particles are intimately linked such that the state of one immediately influences the state of the other, regardless of the distance between them. In 2009, an article titled "First Teleportation Between Distant Atoms" made waves in the scientific community. The scientists involved in the study reported a successful teleportation of information between two separate atoms in unconnected enclosures a meter apart. This was a groundbreaking moment, as it showed that information could indeed be transferred without needing a physical medium for travel. Fast forward to 2016, another article titled "Quantum Teleportation Enters the Real World" made a compelling point. It stated, "The photons aren't disappearing from one place and appearing in another. Instead, it's the information that's being teleported through quantum entanglement." This reiterated the fact that, in quantum teleportation, it's not matter but information that's being moved without traversing any physical medium. So what do these scientific breakthroughs tell us? They provide strong support for the idea that information can exist independently of its physical manifestation. This challenges Landauer's assertion that information is inevitably inscribed in a physical medium. Instead, it lends weight to Roger Penrose's seemingly quaint notion that information has an existence independent of its physical manifestation. It seems that quantum teleportation could indeed challenge the notion that information is purely physical. These experiments and their findings don't just reshape our understanding of information, but also open up new avenues of research in the realm of quantum information science. They bring us one step closer to the realization that information, not matter and energy, might be the fundamental building block of our universe. What if we told you that, according to quantum mechanics, physical reality could be emergent from an information basis? Yes, it seems counterintuitive, but let's dive a bit deeper. Pioneering thinkers in quantum mechanics like John Wheeler, Vlatko Vedral, and Anton Zeilinger have made compelling arguments for this perspective. They propose that the most fundamental definition of reality is not matter or energy, but information. It's a radical shift in thinking, but one that has gained traction within the scientific community. Zeilinger even suggests that this isn't a new idea at all, but rather an ancient understanding, recalling the opening of the Gospel of John. In the beginning was the Word. In this context, the Word can be seen as information, the fundamental building block from which everything else flows. So in light of these insights, we've come to understand that information, rather than being confined to a physical basis as Rolf Landauer held, not only exists independently of matter and energy, but may also very well indeed be the bedrock of our reality.